patreon.com/home automation.
Hello and welcome to my home automation site. I'm Sylvain Mel, and for my first video I would like to start a simple project to get my hands on video mounting tools, but also to introduce you to these electronic components which I'm sure will enhance your life. Since I need a whiteboard to make my presentation, why not to do it with style? I would like to put a backlight on it with a strip of LED controlled by an Arduino Uno. However, the output of the Arduino does not allow enough energy to power up the band, so we will use a relay in a separate power supply. Some part of the assembly will be detailed in the future video, such as using the Raspberry Pi to create a web interface that will serve us to control the lights, and also the MQTT file that ensure communication between components. The project is evolutionary, which will allow to show different ways of doing things. I also included a training section that will be useful in future presentation. You'll only have to add your personal creativity to build your own project. First, to create this assembly, you must build a space between the board and the wall, approximately 1.5 inches from the edge of the board to hide the lights, and at least 1 inch deep to have enough room to put the component. Here is the educational section. Let's now talk about the LEDs. Light emitting diode. Like the standard diodes, the LEDs allow the current to flow in one direction only. However, they emit a light when they let the current flow. Their energy efficiency are remarkable compared to other types of lighting. About 10 times more efficient than incandescent bulbs and 4 times more efficient than fluorescent tube. This makes it a component of choice for our low power assembly. How to choose your LED? There are two large families of LEDs, those who are programmable and those who are not. For the programmable one, a circuit control interface with the LEDs in order to select the state, like the color, the intensity, the saturation. For non-programmable ones, a fixed voltage is applied to the terminal of the LEDs that determine its states. A variety of voltage are available to suit different needs. The luminosity intensity, called lumens, intensify as power increase, meaning volt times amps. By choosing a strip with a higher voltage, we reduce the electrical current to obtain the same luminous intensity. Also, when using a very long strip, we may need to insert a power supply into the path to reduce the electrical current flowing through it. Let's take a closer look at the non-programmable strips. The lights are connected in parallel mode to receive the same voltage across the different terminals. As a result, they turn on and off at the same time with the same state. It is possible to vary the intensity of the light by creating a small power cuts in the power signal. The Arduino PWM function allows you to vary the duty cycle. A clock set at a frequency of 500 Hz or about 2 milliseconds per interval allows you to control the opening and closing cycles. The value vary between 0 and 255, where 0 corresponds to non-current and 255 corresponds to a continuous current. For example, the value of 127 would toggle the state open and close at every 2 milliseconds for a 50% intensity. Remember that the output of the Arduino is only 5 volts, and the output power is not sufficient to power up a whole band of LEDs. The available power vary according to the power supply used. A maximum of 500 milliamps is allowed with the USB port. For example, a LED model 5050 consumes 240 milliamps alone. We will see how to resolve this issue later. Some stripe LEDs have only two connectors, the voltage in and the ground, which limit their state to a single color that is predefined by the manufacturer. Be careful not to reverse the polarity because the main characteristic of the LED is to be able to block the current flow from one direction. Other bands are provided with for connector, the RGB and ground. By combining the different brightness for the red, the green, the blue, you can vary the color of the stripe. As they are all in parallel, it is the same color for the whole band. They light up and they shut down at the same time and at the same intensity. The programmable LED have one extra component, one interface that controls one or more LEDs. One or two additional terminals appear, which are used to communicate information through the controller, the data, and sometimes also a clock. Although the connector that carry the power supply are connected in parallel mode, the data is transmitted in series and it makes them programmable individually. The data signal go from one controller to another. Each of them uses the first value. The first controller gets the first information, destroy it, and transmit the rest of the message to the next controller that do the same. The spread is so fast that it feels like the lights are acting at the same time. If the stripe is very long, it may happen that several signals are circulating among them. Note that since the data signal is sequential, there is a direction for the branching, which is indicated by an arrow on the stripe LED. In general, there are several features to consider when making your choice. Here's a list. Are they programmable or not? Operating voltage of 5 volt, 12 volt, or 24 volts. The number of LEDs light per meter, 30, 60, or 120 LEDs per meter. Is it waterproof or not? The brightness goes from 25 to 250 lumens per watt. The consumption in watt, the type of controller, the size of the LEDs, and the maximum color temperature that can go from 1700 kelvins to 27,000 kelvins. Now let's see how to power the 12 volt strip from a controller like the Arduino. First, it goes without saying that we will need a 12 volt power source that will start and stop as needed. To reduce the intensity of the light while maintaining the voltage of 12 volt, small interruptions of current must be made in order to obtain the reduced luminous intensity. As mentioned earlier, the PWM function of the Arduino is designed for this work. Clock is at a frequency of 500 Hz. By default, the PWM function quickly turns on and off the load that it supplies. A higher frequency reduces the perceptible flicker. It is possible to increase the frequency with a simple command line up to 62.5 kHz. It means 125 times faster than the base frequency. The flicker, then captured by the camera, instantly disappears. There are several forms of relay. Some are mechanical as others are electronic. The semiconductor relay does not have the mechanical part, which makes them silent relay. However, an attention must be taken to the output current because some models are operating in DC while others are operating in AC. If you use an AC output model and plug in a DC power supply in it, it will turn on at the first input signal and will remain until you turn off the output current. Mechanical relay. They work with alternative or continuous current as an output. However, they are noisy and cannot be swung quickly to decrease the intensity of light because of the response time that is associated with the mechanical movement. It's a coil which, when letting pass an input current, creates a magnetic field which turns on a switch over the output circuit. The circuit is completely isolated from the input. Normally open relay are found, others are normally closed, and often the two functions are found in the same relay. We must therefore find an alternative to combine the silence of semiconductor with the ability to take control of continuous current while supporting a high frequency of polarity changes. This is the case for transistor. To simulate this, it is like using a small amount of water at low pressure to open a valve that will allow more water to pass through a higher pressure in the hose. The output pressure of the hose is therefore proportional to the one that controls the valve. It was understood that the water pressure corresponds to the voltage and that the amount of water corresponds to the intensity in amps. We're almost there. Since the voltage control is relatively proportional to the output, we want to have an output voltage to be 0 or 12 volt. We should then control the input with a square wave current of either 0 or 5 volt. In fact, there's a minimum threshold of 0.3 or 0.7 volt depending on the model before the output current can begin to pass. Similarly, there is a saturation threshold which also varies according to the model, beyond which the output current reaches its maximum current. Between those two thresholds, the input current and the output current is substantially proportional. Therefore, it must be remembered that by inducing a voltage lower than the minimum threshold, there is a power cut, and when we induce a voltage higher than the saturation threshold, we allow the current to pass completely. Let's now look at the code to control the intensity of the light through an MQTT queue. Two libraries must be included, one for the network access and the other one for the message queue on the MQTT server. We then declare our variable PWM1 and PWM2 for the intensity of the light before and after the change of intensity. We also use a variable to determine which output will be used by the Arduino to communicate with the LEDs. This way, if we want to change the output pin, we only need to change the code at one place, and it makes the code easier to understand. The other variables are used to configure the network adapter. The callback function is called when a message arrives into a message queue where we have subscribed. By taking the message one letter at a time and by a set of of copy to different data type, we end up converting a character string char into an integral int using the atoi command string to integer. This result is placed into a variable pwm2, which will be later used. The reconnect function ensures the connection to the MQTT server. The setup function initializes the library with correct parameter and specifies the desired frequency for timer 0, which will be used to generate the frequency that controls the LEDs. Finally, the loop function is the logic to be applied through the execution of the program. The change status is validated to avoid unnecessary manipulation. The future reference PWM1 is updated and the desired lightning power is indicated so that the LED adjusts to the desired intensity. We now have a fully remote controlled board. In the next video, the installation will be modified to have a color LEDs and programmable, controlled by a Wi-Fi interface rather than Ethernet interface. By the next video, remain curious, and if you enjoy, don't hesitate to share with your friends, to like on social network, and especially each contribution you make allow me to invest more for you. Thanks for your generosity and see you soon!